Steel. It's used in everything that humans know. From your car frame to office supplies to even this pocket knife right here, steel has been an essential part in how humans move and operate. But how did this benign metal come to exist? Today in this documentary, we'll be explaining the evolution of steel and iron production, which has led us to prosperity throughout the ages. Join us today on FT National as we explore steel and iron in its greatest capacities.
It's hard to aim, ho! I love steel! Oh my god, everything is big!
I love steel! Look around us. Steel is all around the world, especially here. We're here in Gasworks Park in Seattle, Washington, where, as you can see, everything is made of steel. It would be iron that led to the establishment of trade within the North Americas. As colonists began to settle the continent, they brought with them ironworks, such as knives, pots, pans, and kettles, other materials that the natives could use in exchange for their beaver pelts and food.
These deals bolstered trade, but forever changed the landscape of America, as European traders flooded into the wilderness for excess resources and natives had access to deadlier weapons and technology.
The English have no sense. They give us 20 knives like this for one beaver skin.
We are currently driving to the location of the first recorded iron mill in the Americas, in Falling Creek, Virginia. The mill frightened the natives, who were infuriated by the loud and chaotic behaviors of the colonists in stolen land. Before the colonists could even start foraging, they were attacked and all 348 members of the colony were killed by angry Native Americans. It wasn't until over 20 years later that the Hammersmith Company built some ironworks in Saugus, Massachusetts.
The first iron furnaces were small operations, built close to local ore supplies, water power, and major water transportation routes. Originally set up by Great Britain in order to bolster their iron output, these mills began to produce iron for themselves, eventually outputting as much iron as Great Britain herself. These mills were established in areas such as the Delaware River in Pennsylvania and the Hudson River Valley in New York and New Jersey. The reason for their small size was high costs and low fuel efficiency of the wood that was required to be used in the smelting furnaces. Now, the switching from wood to coal in the 19th century allowed for larger operations to pop up. And the discovery of iron ore deposits in the Great Lakes during the 1840s gave a further boost to production. Steel is created when oxygen is blown through pig iron, reducing the level of carbon and removing other metals until the substance is purely an alloy of iron and carbon. This alloy is stronger than cast and wrought iron, allowing for a better quality in products and stronger structures, machines, and weapons. This process of production was only just perfected in the last 19th century, and with the surplus of factories and jobs, elevated the United States to the global power it is today.
Right before the American Revolution, 80 furnaces were supplying Britain with about 30,000 tons of iron every year. This made them the third largest iron producer in the world. After the Revolution, they found that they're in a pretty good spot to start producing more iron, as they could build closer to iron deposits and use the excess wood on the East Coast.
During the 1860s, the rise in iron use led to the Industrial Revolution and the building of more railroads. However, the iron in these railroads would often splinter, causing tracks to get damaged and derail. Steel could not be used because it was too expensive to be produced at this time. However, that changed in 1856 when Henry Bessemer created the Bessemer method of making steel easier and cheaper to produce. A blast of air would heat the steel to 3,000 degrees Fahrenheit, removing carbon and other impurities from the steel, making it purer and a higher quality.
Andrew Carnegie revolutionized the steel industry by utilizing vertical integration to create a monopoly on steel production. He began by first buying steel mills and then buying the coal companies that would heat the furnaces for the iron workshops, and then eventually he bought the iron mines that supplied the iron. Yeah. And then he founded a company, Carnegie U.S. Steel Corp. In 1901. By controlling every aspect of the steel production, Carnegie was able to keep prices low and profiting high. The U.S. Steel Corp. was the first billion-dollar company in the U.S. Probably in the world, actually.
Yeah, in the world.
In the world. Yeah. The heightened production of steel had a vast social and economic consequence for America. As the operation expanded, managers needed more complex skills. Produce development, marketing, and consumer preferences became important. Competition was fierce. America became industrialized and labor changed. The success of Carnegie embodied the American dream of a self-made man as he came from nothing. Dirt. Nada. Yeah.
First of all, where are you from?
Now, I came to America as a small immigrant from Scotland, and I ended up working as a bobbing boy in a cotton mill. Eventually, I ended up working on the Pennsylvania Railroad, where I was elected regional superintendent by the age of 24.
How exactly did you get so rich, Mr. Carnegie?
Well, I got rich by beginning with investments, and then I built the J. Edgar Thompson Steel Company, and you could say I was a pretty good salesman.
Aren't you a hypocrite, though? I've heard a lot about how you've treated your workers.
Well, I have written stuff on the social gospel of wealth and the money to poor communities, but I didn't pay my workers much, and I didn't allow unions in my companies.
How's the steel industry, though?
The steel industry is pretty good. I invented vertical integration, which helped with the production of steel, and you could say that went pretty good.
I hate this project.
Thank you so much, Mr. Carnegie, for coming in and agreeing to talk with us. We appreciate it.
You're welcome.
Workers of the steel mines lived in mill towns, where the company controlled all the aspects of its workers' lives, making strikes and uprisings dangerous and risky. The workers had to work in extremely hot and dangerous conditions, often with little to no safety procedures.
Hard? I guess it's hard. I lost 40 pounds the first 3 months working here. It drains the sweat out you. I often have to drink 2 buckets of water a day just to get through the day. The sweat drips down my sleeves and my pants, and it drips to my shoes.
We're interested in anything having to do with iron and steel right now. Like anything that you can provide us with the history of it, how you guys make it, or like how it's distributed, anything like that. That'd be really useful.
We're on our way in the first step of figuring out how steel is made. We're off to Jorgensen Forge, which is right down the street from our high school, to see how they forge metals in these huge furnaces. And crazy shit. Yeah, crazy shit.
So specifically Jorgensen, more works on more like high-tech stuff. It's forging, but it's, you know, it's aircraft carriers, submarines, and rockets, and not so much our general use products. So if you went to Nucor, which is just up the street, they make sheet metal, and they make, you know, they make bars, they make structural components. So like all the space, all the, can't see anything from here, it's too, but all of the skyline is all steel. That's how it's made. So, I mean, it's used in every structure and vast impact on steel and the development of the U.S. And kind of how we talk, westward expansion, as you mentioned. And modern history is not possible without steel industry. I mean, that's a very clear statement, very true statement.
So, where do you think the steel industry is heading in the future?
So I expect it to decrease, I guess, in the U.S. I think it will continue to decline. And the reason why is kind of critical. Like, there's no research and development made into steels anymore. It's old technology, and we're still using it all the time. So I think there's a decline in the U.S. steel industry, regardless of what we do, because we're using other products to make those parts. We're never going to replace a skyscraper with composites or something like that. It's just not going to happen. We're not going to replace it with concrete. Not going to happen. So, I mean, there's material selection or material design that you have in place, and steel's never going to be removed from that design equation in a lot of applications. So, it won't ever disappear, but I think it will continue to decline.
Documenting is a lot of work. Could probably just run to the other place as well.
So we're currently at Standard Steel Fabricating to get a tour of their steel factory.
This is Standard Steel Fabricating Company. They've been around since 1936, and we're about to go in and see how steel gets from the drawing board into the buildings that we see all around us. As such a long-time company, they use a lot of long-time operations, and we've been so lucky as to have been offered a tour throughout the entire facility. Let's check it out, guys.
Yeah, I guess that's another thing. All the different tariffs that are starting to come in. Is that you don't want to talk about?
No,
that?
don't drink that Kool-Aid yet.
All right.
The tariffs were just a bargaining chip put down.
Yeah.
The mills were only running at 80%. The tariff was up to 22%. The mills have raised their prices 15%.
Just to take advantage of it.
Exactly.
Yeah.
Also, the mills are coming up from where they're running at an 80% production up to 90% production. You're always going to have a 10 to 5% production for die changeovers and maintenance.
Yeah.
So now they're coming up to 90-95%. So these tariffs are nothing more than a bargaining chip. And if you do look at the tariffs and you look at the EU's tariffs in this, it's a bargaining chip.
Yeah.
I don't think it's a bad move, to be honest with you. But you're going to feel it. The other problem is we don't have all the manufacturing to cover all the product. That is an issue.
Yeah.
But I think it will all balance out. We've seen about a 20 to 25% increase in the past 5 months. You just got to plan ahead when you bid a job and go from there.
The early 1980s created a new era. As transportation costs declined, Brazilian producers entered the market and started delivering iron ore to steel producers in the United States at a lower price than the miners in Minnesota. This led to change within the industry. Iron ore producers doubled their productivity within 5 years, adopted better work practices, utilized machinery more efficiently, and innovated new mining practices. This competition is what caused the American steel industry to better itself. The current operating and steel corporation includes 100 steel supply and production facilities, employing 140,000 people and supporting the lives of nearly 1 million Americans. As of late, the steel industry has been facing some challenges. Still, there are amazing projects going on all around us, and production continues strongly. We spoke to some experts to get their take on the direction of steel in the 21st century.
Who's going into engineering?
We all are.
How many engineers does it take to screw in a light bulb?
Never happened.
Close. None. Why? The world revolves around them.
The process for making steel changed.
For the raw steel changing? You've gone more to the mini mills, electric arc furnaces from the original blast iron furnaces and utilizing more recycled content, going to a continuous roll.
Do you know when that change come around?
That started coming around, if I remember right, don't quote me, I believe in the 70s. Nucor was the first to come up with the first mini mill, and they were doing a continuous roll. So they're bringing all the material, putting it in a huge kettle, electromelting it. It continually pours out, goes out a steady stream, and they do their castings that way. Compared to when it used to be done in the blast ovens, then into billets, and then the billets then would be rolled and re-rolled and reheated and re-rolled. So there's been improvements.
That makes sense.
Steel industry is always advancing. The changes have been come. I mean, the biggest change you saw was welding. I've grown up in this industry from shipbuilding from the 1900s. This is what I know. The advancements that have come with steel, especially in tubings, is better ductability, higher for compressions, higher grades, more flexible grades, things that have been learned from earthquakes, 3D printing, and I think the advancements are going to come that will benefit all. It's going to be about quickness and ability to do things and life safety. Life safety is the number one thing. If you're in a building, the benefit to the people is their lives. You know, if and I'm kind of going off topic here, but I did sit with Mr. Magnuson. And Mr. Magnuson, we were at a breakfast one day. He designed World Trade Centers. Okay? And we're talking, and we're steel guys and quasi-engineers. And I said, wow, that thing was amazing how it did that. It was, especially when we only designed it for this. and we were talking through everything, because World Trade Center was one of the first clear span structures for steel. As with steel, you get limited to smaller grids. This was a larger clear span with baffles and truss work. And that's where steel is advancing, more long span open space. But we were discussing that on how it did and how it responded and how it loaded and went from there. A little dark, but steel guys, it's okay, it's happened. Why did it happen? How did we not get it to happen again? But it was never designed for a plane that size to hit it.
We just got back from our tour of the Standard Steel Fabricating Company. What do you guys think?
You know, it was pretty cool.
It was pretty cool.
It was pretty metal.
He was a very nice man that showed us the things about steel.
He had a good grasp on the economy and how the steel industry is going. I really felt his sort of radiance and his knowledge in the field, and it really helped enlighten me to know more about steel and help work on this project that I'm not a part of.
That's
all
for
today.
Folks, join us next time on FT National as we go back in time to the Stone Age. Who's gonna turn it off? Documenting can be stressful. That's why we're here at Island Teriyaki, to take a break from our busy lives.
And it better